You're listening to Autumn on the Air, the weekly podcast that brings you conversations about the impact of research commercialization and the people who make it happen. Join us for interviews with patent and licensing professionals, innovators, entrepreneurs, and tech transfer leaders on the issues and trends that matter most. Keep listening for an inside track on the people, IP policies, and politics changing our world.
Welcome to Autumn on the Air. For July, we are kicking off a very special series in honor of Disability Pride Month, a time to celebrate the achievements, experiences, and diversity of people with disabilities, especially in the fields of science and technology. Throughout this month, we'll be spotlighting leaders who have not only advanced their fields, but have also paved the way for greater inclusion and accessibility. I'm honored to welcome Dr. Geerat Vermeij, a professor emeritus of Earth and Planetary Sciences at UC Davis, for our opening episode. Dr. Vermeij is a world-renowned evolutionary biologist, a MacArthur Genius Fellow, and an accomplished author. Blind since the age of 3, Dr. Vermeij's career is a testament to resilience, curiosity, and the power of diverse perspectives in science. His groundbreaking research on mollusks and evolutionary adaptation has shaped our understanding of life's complexity, while his advocacy continues to inspire scientists and innovators around the globe. Today, we'll begin by exploring Dr. Vermeij's scientific journey and research, then discuss his experiences navigating academia as a scientist with a disability, and finally reflect on the meaning of disability pride and the importance of accessibility in research and innovation. Welcome to the podcast, Dr. Vermeij. Really excited to have you here on the air.
I'm delighted to be here.
Well, Dr. Vermeij, I thought maybe the best place to start the podcast is to talk about your scientific work because you've had a tremendous impact. And in fact, your research on mollusks and evolutionary biology has been extremely influential. Tell us about some of the discoveries you've made that you're most proud of.
Well, I have to say, I guess I'm proud of a lot of things, but, some of the early insights were very influential. And the one that I guess stands out for me is the idea that shells are defensive against predators. And the way I figured it out is by observing that, shells get damaged. And of course, as a shell collector, I didn't like damaged shells, but it occurred to me that they're trying to tell me something. And what they told me is that, yes, shells get damaged, but not necessarily lethally damaged. And so they are adapted to a regime of intense predation by shell-crushing crabs and fishes and any number of other predators. So that's how an awful lot of my career kind of got started, or at least got enhanced early on. And so an awful lot of what I've done since has been a variation on that particular theme.
Yeah, and tell us a little bit more, speaking on this whole arms race between predators and prey, what you've learned about adaptation and resilience.
So the main thing that I learned after spending all kinds of time in places like Guam and Panama and Jamaica and so forth is that these adaptations that I just spoke about are relatively recent in geological time. So if you look at really ancient shells, they don't show these kinds of adaptations at all. And that tells me that what I call escalation between predator and prey is a process that has resulted in really spectacular adaptations in relatively younger periods. So the process, you can look at the process over long stretches, I mean, many millions, many hundreds of millions of years, and see not just a progression in armor versus predator, but also in locomotion, in venom, and all kinds of other traits.
I'm curious, you mentioned several places you've been. Where has your work on studying this evolution between mollusks taken you? It sounds like it's taking you throughout the world.
It has. Now, we've spent an awful lot of time in places like Guam, Panama, Jamaica, but also I've been to New Guinea in Australia and the Aleutian Islands in New Zealand and West Africa and Madagascar and lots of other places. So I have this very broad sense of how things vary in space. And I also have a particular love for the tropics, by the way. And I think every biologist interested in organisms ought to go visit the tropics. But my work has also taken me to cold places, which I don't tend to like, but they're extremely important in how I think about things. So the Aleutians was quite a challenge, but absolutely fascinating.
I would imagine so. Is there any particular reason why Guam, Panama, and Jamaica, other than the fact that you like the tropics? I'm assuming there's a scientific reason.
There is, and the main one is that there are institutions there where you can work. So the University of Guam has a marine lab, which was begun shortly after my second visit to the island. Panama has the Smithsonian Tropical Research Institute. It's a wonderful place, which I hope isn't in peril at the moment. And Jamaica has a very good lab at Discovery Bay on the north coast of the island. And I've been to various other marine labs as well, but those three really do stand out for me.
Now, given that you've been all over the world and you've spent an entire career studying mollusks and evolutionary biology, were there any particularly surprising or groundbreaking findings from your work that changed the way you thought about evolution?
Well, again, the main one was to connect geological history with modern adaptation. To have that temporal dimension was absolutely critical. And of course, although mollusks remain my great fascination, I've also expanded my thoughts to other organisms. So I've written several papers on plant defenses, for example. And I got very interested in geography, the geography of life, and the geography of extinction, and many other phenomena. So I've gone well beyond that initial interest in armor and predation. It's always been a means to an end. The end being, I want to understand how the world works and how it changed. So that has been the trend of my scientific life.
So tell us a little bit about what you're working on now, maybe some current projects or questions that you're particularly excited about.
Sure. Well, I'm working on another book about what it's like to be a scientist, but also with my colleague Tracy Thompson, I'm working on the evolution of semi-aquatic mammals that live, in other words, in part in water. And although you would think that this subject was well understood, there are lots of aspects of it that we are discovering and having all kinds of fun with, finding out how many mammals there are to have done this. It's up to about 70 independent cases now. Yeah.
I wouldn't have thought it was anywhere near that number.
Most other people wouldn't either.
Yeah, exactly.
And this also extends work that I'd done earlier on marine mammals and marine vertebrates generally, and work on gastropods, which have gone the other way, from marine to freshwater and from marine to terrestrial. And again, every time I've looked, the number of independent cases has been much higher than anyone had previously thought. So this is, again, part of a larger project trying to understand evolutionary transitions, taking fossils into account.
So, Dr. Vermeij, given the breadth and depth of your career today, how do you see the relationship between diversity in science and the advancement of knowledge?
So I've long thought that diversity of perspectives in science is extremely important. you know, my perspective on it is different from that of, say, a molecular biologist or a geneticist or a physicist for that matter. And I think the number of approaches and ways of thinking about problems is important. We should not have unanimity in how we approach things. So that is the sense in which I think diversity in the human context, for me, is the most important.
Now, I'm curious to get your opinion on what you think are some of the biggest unanswered questions in evolutionary biology today.
I think there are still questions. There are lots of questions, of course, but one of them, surprisingly enough, is about natural selection. People talk about natural selection all the time, especially geneticists do, and they infer selection from changes in gene frequency. I don't necessarily agree with that, because a change in gene frequency could have any number of other causes. To me, it's important to identify natural selection in an ecological way, and surprisingly few people have done this. So that's one issue. There are also many problems which do not take the fossil record into account. I can't tell you how many people have written papers about trying to infer evolutionary processes from just modern species. You can't do that. You have to look at fossils. You have to look at things in the distant past. So there's lots of that going on. There are, of course, also outstanding questions about where things like consciousness comes from in humans and perhaps other so-called higher primates and other mammals, perhaps octopods. So there are lots of unanswered questions about how things came to be. And then, of course, there are issues about, well, what are the evolutionary effects of climate change, undeniable climate change? And, there's no doubt we're undergoing a climatic warming, a significant climatic warming, especially in the oceans. Well, what are the effects? Well, one way to find out is what the effects were in the geological record. Surprisingly few people have tried this. So there are lots of things.
No shortage of topics for sure.
No.
Yeah, definitely too much to do and too little time, as they say. And, you mentioned a few minutes ago that you're working on another book, and you've written several books. And I did want to ask you about one of them in particular, The Evolution of Power, A New Understanding of the History of Life. And it's a great book. I've started reading it, and it reveals how the concept of power unifies a vast range of phenomena in the evolution of life. Tell us a little bit about the book, what motivated you to write it, and what it talks about.
Sure. Well, people have always recognized the importance of energy in life. You can't do anything without energy, just as in economics, in modern economics anyway, you can't do anything without money. But energy and money don't do anything for you unless you use them. And use entails time. So power is energy per unit time. And therefore, the element of time is absolutely crucial. Well, if you think about our way of life and metabolisms, then you have to assume that time is of the essence. And so instead of talking about energy, we talk about power. So I've long thought about all this stuff. And it struck me that it was a good time to put it all together. I had written some earlier papers sort of summarizing my views, but here I had the opportunity to really put it all together, at least as far as I could. And the main theme, to make it somewhat simplified, is that power has increased over geological time among organisms, particularly among organisms that are competitively powerful. Those powerful organisms, such as humans or octopuses, mentioned them earlier, crabs, and so forth, have an effect on organisms that have less power, but they enable those less powerful organisms to exist. And so we see this whole unification being quite literally driven by competition and predation, favoring power at all scales. And we see this throughout the geological record, although there is evidence for its having speeded up in the last, let's say, 100 million years or so. So that's an aspect that's also very interesting and deserves a whole lot more research than it's received so far. But this whole idea of synthesizing from a great variety of topics, from plants and animals and even microbes, is a wonderful thing to try to do. And it's been kind of the theme of my scientific life.
It's an incredible book. Like I said, I just recently bought it and started reading it. It's fascinating. And that's why I wanted to talk about it today, because the topic the topic is something, it's very creative and something I hadn't really thought about until I started reading the book.
Well, I guess you might say that most other evolutionary biologists haven't really thought about it either.
There you go. Yeah, exactly. So I want to shift now and talk a little bit about your personal journey. And I understand from some reading I did that very early on as a young boy, I think maybe at the age of 10, you started collecting shells. So I'm curious how some of your early experiences shaped your passion for science, and how did you end up deciding to pursue evolutionary biology?
Right. Well, as far as I can remember, and my memory goes back very far indeed, I have always loved natural history. Formerly blind at age 3, I never saw very well because I had childhood glaucoma. And so my parents were phenomenal in showing me things. So was my brother, my older brother, Ari. So the interest in nature has always been there. But when we came to the United States from the Netherlands at age 9, I was age 9, I got my birthday on the ship coming over. I was introduced to shells from Florida. Now, I had always picked up shells on the beaches it all made immediate sense to me. And, as far as, of course, I didn't understand much about it, but the whole process seemed kind of natural. And so I pursued a biology undergraduate degree at Princeton, and then took a PhD at Yale, also in biology, but spending a lot of time in the geology department, where I learned a whole lot about fossils and so on. So the career has actually been pretty steady, you might say. And the interest has always been there from childhood on. I started reading the scientific literature in high school and became a member of a malacological society when I was 16. I'm still a member of it, and probably the longest serving member in the society. And so it's just been kind of a straight line.
That's pretty amazing, especially for a young kid to know so early on what he or she wants to do is pretty rare. But
it's rare, but not all that unusual. There are many people whom I know who were bitten by this bug very early on as children.
Yeah, and it sounds like it was a collective family kind of experience. Your parents were so into nature, yeah, and your brother.
They were all very, very engaged.
It sounds like it. It sounds like you guys all shared a common love, which was nature and the outdoors.
Right. And the funny thing is that my parents were not excessively well educated, but they had exactly the right attitudes about all these things. And they had nothing but encouragement. And I might say many of my teachers likewise did, for which I, of course, am eternally grateful. You don't do any of this without a lot of help and encouragement from others. I would never, ever claim that this is all my doing. That would be foolish. I've had wonderful, wonderful mentors all through my childhood, my college career, PhD, and subsequently as well. It's been a very good journey that way.
So you mentioned you had glaucoma and you really had trouble seeing as early as since the age of 3. What were some of the barriers you faced as a blind scientist, and how did you work to overcome those?
Well, surprisingly enough, I would have to say there have been relatively few.
That's great.
And I think this has to do with a number of factors, some of which are indeed personal, but I think somehow I convinced a lot of potential mentors to be highly supportive. And I think this is important. I did have a few, incidents where people were doubtful or dubious or perhaps negative, but there have been very, very few of them. One that might be worth telling very briefly is I was invited on this cruise on the Alpha Helix to go to the Aleutians, which I had very much wanted to do. The University of Alaska, which ran the ship for the National Science Foundation, said no, you can't have a blind person, that would endanger the crew and all the rest of it. I pointed out to them that I had been on that exact same ship with my wife, as it turns out, in New Guinea and Northern Australia, Indonesia, and the Philippines, not exactly safe territory.
Yeah, exactly.
And we had done just fine, thank you very much. After quite a long correspondence and cajoling and so forth, they finally relented. And I pointed out in a subsequent article that, the Aleutians are definitely a dangerous place. Let me make no two bones about that. One of the most dangerous things you can do is to shift from the ship to small boats and landing on islands. Well, as it turns out, I had only one incident where my boots filled with cold water, whereas most of my colleagues had multiple cases.
Oh, that is too funny. And given that, were there any practical strategies or tools that enabled you to conduct your fieldwork and research that were, maybe different than others would use, or not really? Were you able to adapt pretty well?
Well, I'd have to say I adapted pretty well. And the reason I did is because everywhere I've ever worked, I've always had assistants, sighted assistants. In the last couple of decades, that's been my wife. But before I met her, I had all kinds of assistants, local people who were really very good. One case, I was in Fiji for a UNESCO conference, and they took us to a small island south of the main archipelago, and everyone else was diving. I do not dive. I want to retain my hearing. But I did want to look at the shore, and someone in the village said, okay, well, we'll find you someone. And they found me a 14-year-old boy who turned out to be superb. And so working with assistants who can describe the lay of the land and take me places and just generally, it's always good advice for anyone in the field to be with somebody else. So that's been extremely important, obviously, having assistance.
Absolutely. And I want to go back to something you mentioned a little bit earlier, which was mentors and role models. Talk a little bit more to us about how they impacted your journey.
So all of my role models have been cited. That's number one. When I was at Princeton as an undergraduate, I had several professors who were profoundly important to me. They were also uniformly enthusiastic and very, very influential. So there was Alfred Fisher, there was Robert MacArthur, there was Egbert Lee, there was Henry Horn. And these are really wonderful people who went out of their way to help someone who obviously was really interested in what they did, and who really was anxious to learn. And of course, all along, I've had other people who have been helpful in the same way. I've also had people who work with me as readers. In fact, that's an extremely important part of my current life, is reading scientific literature and taking notes and developing a gigantic, gigantic Braille library. This is how I've worked. It may not suit everyone, but it suits me.
Well, I also want to ask you, given the breadth and depth of your career, have you encountered any ableism or maybe misconceptions? I'm sure you've had misconceptions about your abilities in the field, and I'm curious how you've addressed them or challenged them. I mean, you mentioned the ship in the Aleutian Islands, how you challenged those, but I'm sure you must have some other examples as well.
Yes. So the first time I wanted to go, I was in Hawaii for a course that the National Science Foundation sponsored. And I was in Hawaii and I kind of wanted to go to Guam. And one of the professors who taught at this course, a wonderful man named Alan Cohn, knew someone in Guam. And so he contacted Lou Eldridge. And Lou Eldridge, who was at the University of Guam, thought he was a little bit skeptical. And he said, "Oh, we'll give it a try." And so he did. And on our very first day, the day I landed, he took me to a couple of sites along the coast. And I think that overwhelmed him in terms of, oh gosh, he knows what he's doing. And he became a strong supporter subsequently. Likewise, when I went on my first Alpha Helix trip, the captain, the would-be captain, said, "Are we sure about this?" And I wrote him, and he subsequently said, "Okay, fine, go ahead, no problem." And all was well on that trip as well.
Yeah, I mean, you've done amazing throughout your career. It's really incredible, and I'm curious, what changes have you witnessed in academia regarding accessibility and inclusion since you began your career?
Well, for me personally, not much, because I've had a very successful career from the beginning. I was lucky. I got tenure within 3 years. I was very young when I started. Anyway, I was 24 still when I started my first teaching job, which is unheard of these days. And when I came to Davis, I was invited here, and there were no significant hurdles here either, and no one has ever been unsupportive, I would say, in the departments I've worked in. Perhaps privately, people had questions, and there are certainly things that I might have done better than I ended up doing. I'm not great on service, for example, and never made any bones about that either. And I'm sure people criticize me for that. But I have never experienced real hostility or naysaying, at least not to my face.
So, what advice would you give to young scientists with disabilities who might be considering a career in STEM?
I'd give them the same advice I would to anyone, which is you really have to like what you're doing, and you have to work really, really hard. And it would be very good to have a very strong curiosity about the world and to have a sense of what's important and what's not. That's a lot to ask, but science is hard. There's just no two bones about it. Science is hard, and you got to love it to do it as a professional. Now, I think every person in the world ought to know enough science and ought to be aware of what science is and what it can do and so forth. I think every single person ought to have a basic science understanding, but doing it professionally is a whole different thing. Now, in addition, I would have to say, particularly for blind people, instead of just relying on the computer, for me, one of the great time-saving pursuits that I have done throughout my academic career is to have readers. They are so much faster than anything I could do on my own. Not only are they faster, but they can say, look at a reference quickly. And it is, and it's also, by the way, and speaking completely personally here, it's how I met my wife, who was a reader for me at Yale. And it's an opportunity to get to know people, and for people who are as socially inept as I am, that's a great benefit.
Yeah, I would imagine that that's been a great connector for you in terms of connecting you with so many people, probably all around the world. And you mentioned the boy on the beach. So yeah, that makes a lot of sense. What do you think that institutions and colleagues can do to better support scientists with disabilities?
Well, there are obviously things that people with disabilities need that other people don't. And in my case, that would be readers, and that takes money. There have to be some kind of accommodations. There's just no way of getting around that. So there has to be enough flexibility and enough financing to be able to accommodate, to put in those additional accommodations. There's no way around that. I have generally not had trouble with this, but I can see where in a world with less funding and generally perhaps less interest in science, this might turn out to be a problem.
Yeah, it's going to be very interesting to see how the next few years develop on that last point that you made.
I am not optimistic on that score.
I'm afraid I'm with you on that one. I'm not optimistic at all either. So are there any cultural or maybe policy changes you'd like to see in STEM to make sure that everyone can contribute fully?
I've had a long time view that we should pay less attention to people's identities and more to what people can do. So I don't want to be judged on whom I am. I want to be judged on what I do. And I think that is an important reorientation, which I think should enhance attracting people of different perspectives. And that's why I think that's the style of diversity that I support fully and wholeheartedly. So I have never had any trouble thinking that people of all races and men and women and so forth should be in science if they want to be. I don't think we should cajole them into it. It's much too hard for that. But I am always fully supportive of people who want to do these things, and we should give them those opportunities. But again, I am not in favor of doing this because of what race or gender or whatever else we are. I'm more interested in what we can do.
So, Dr. Vermeij, as the podcast comes to a close, I wanted to ask you, looking back at your entire career, what are you most proud of regarding your impact and your legacy?
You know, I'm probably not the best person to ask about that because impact is something that other people feel. I'm proud of my career. I've obviously had mistakes. No scientist that I know doesn't make mistakes. I've made some. I hope not incredibly important ones. But what I am most proud of is the journey, I suppose. The idea that you recognize something interesting and you pursue the larger questions that research has made possible. So I'm a big believer in asking questions. And I think the whole idea of asking scientific questions that are, in principle, at least answerable, has been what I'm all about. And to me, the contributions that have flowed from that perspective have been a source of both pride and great pleasure.
Well, Dr. Vermeij, this has been really an incredible honor to have the chance to talk to you about an incredible career focusing on mollusks and evolutionary biology and all that you've done. Thank you so much for your time and spending time with us today on the podcast and kicking off our Disability Pride Month series.
Well, thank you very much for having me.
Dr. Vermeij, thank you for sharing your remarkable story, insights, and advice with us today. Your journey exemplifies the spirit of Disability Pride Month, embracing difference, challenging stereotypes, and demonstrating that disability is not a barrier to excellence, but a vital part of human diversity. As we continue this series, we invite our listeners to reflect on how we can all foster greater accessibility and belonging in our communities. Disability Pride Month reminds us that everyone deserves the opportunity to innovate, lead, and make an impact. Thank you for joining us on Autumn on the Air. Stay tuned for more inspiring conversations throughout Disability Pride Month. And remember, representation matters, inclusion drives innovation, and together we can build a future where everyone belongs.
Thanks for listening to Autumn on the Air with Lisa Mueller. Get social with us and share your thoughts. You can tweet us at AUTM or visit us online at autm.net. We'll be back next week on the air. Be sure to join us.